on.
Yep.
I'm on air. Okay, do me a favor and get out the worksheets, please.
For what?
Yeah, the packet.
All of them? Integration.
Integration, yeah. Oh, not all of them.
Miss K?
Yes.
So then October, November 2006, number 8, it doesn't give you like a visual, and then it's y equals 6 over 5 minus 2x.
How about I do that one?
Yeah, so wouldn't that be an asymptote?
Not necessarily, because it's just a portion of the graph. It depends on where they want you to do it from.
So they would only care about like the
From 0 to 1.
So they would
Right.
give you that?
They give you that. But
So-
yes, you're right. It has an asymptote, but the asymptote doesn't fall in that range. The asymptote. Let's look.
and that one's kind of hard since they don't give you a visual. You have to kind of
You
make
have
it
to
yourself.
right. You just have to know the steps. So
Yeah.
you don't really have to draw it, which is kind of a cool thing. It says the region between the curve and the x-axis and the lines x equals 0 and x equals 1 are rotated about 360 about the x-axis. Show that the volume, given me the volume, is 12 pi over 5. Okay? So, he is 100% right that this does have an asymptote. Where would the asymptote be? Yeah, you set this equal to 0, you set the bottom, and so you add 2x, divide, so if I'm looking at it, I got 5 minus 2x equals 0, 5 equals 2x, 5 halves equals x. So the asymptote occurs at 2.5. So you are 100% right. If we have an asymptote in the problem, we got to be careful because is that part of where we're rotating? But this is telling me to rotate, and it wants me to rotate from the curve to the x-axis from 0 to 1. So what are my walls on this thing? 0 and 1. Where does the asymptote occur? 2.5. Does that make sense? So I'm looking at curve, x-axis, 0, 1. 2.5 is out there. It doesn't even affect what this rotation will look like. Did that make sense, what I just said? Believe?
I'm just going, keep going.
No, so I want to make sure you get that. See, there's a no-no spot here, and that no-no spot is the asymptote, where it causes a 0 in the denominator, right? So if I set that equal to 0, I discover that it happens at 5 halves, 2.5. So I know that, and I don't even care what this thing looks like, but I know from 0 to 1, curve, floor, right? So it's only going to go from 0 to 1, whatever my curve looks like, to 0
So
to
it's
the
like
x.
all of that you just said was like irrelevant to this.
Right, so 2.5
It's just
is
showing-
out here. His question was, there's an asymptote in the problem,
Right.
how is that going to affect the rotation? Well, it does not in this case because
If it
I only
was-
care from here to here.
If it was.
They wouldn't.
Oh.
They wouldn't. They would never, right? So we're going to go around, and we don't care about 2.5. Whatever happens over there, it's not part of my visual picture. Yes?
How do you know what the asymptote looks like?
Well, how do I know where it occurs is at 2.5, because that's what causes that denominator to be 0.
Which is a no-no.
An asymptote goes like this. So
Right.
something happens on the left of the asymptote, something happens on the right of the asymptote. It really don't matter what it really looks like. Yes.
Isn't it an asymptote like where it goes like this and then this,
That could
or
be one of the,
or this and then
Right,
like where they never
exactly.
touch or cross?
Correct. So this thing could come up like so, and that could come down like so. You know, so that's the kind of thing that's happening here. To be honest with you, they're not looking for you to create the visual of it. They just want you to find the volume of it.
Uh-huh.
So we know how to find the volume through the series of steps that we've learned. Okay? So things that I have to ask myself, am I having a party or not? No party.
No party.
No party. I know no party. Why? Because I'm rotating about the x-axis, right? So the second question I ask myself is, am I attached to the place at which I'm rotating? Am I attached to the place at which I'm rotating?
Yeah,
Yes. So therefore, there's no hole.
Mm-hmm.
Does that make sense?
So we use the disk method.
Right. So we're going to go pi from A to B. What's A and B?
1 to 0.
Okay. 0 to 1, right? What's my radius? It's this thing is the ceiling. Yes,
Why are you using copy?
the formula is pi r squared.
Or we're still in here?
Yeah,
Okay.
yeah, rotation of the,
Alright.
basically you're finding, remember when I gave you the little, if I cut it, you see a circle, if I cut it, you see a circle, remember that? That whole game.
The
plan that we
Hershey's?
did? The Hershey's.
Wait, did we get a packet on Thursday, by the way?
We had a packet from 2 weeks ago, we're using the same packet.
Oh, okay.
Okay, so this thing is rotating, 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 touching the place at which it rotates, no hole. So my ceiling minus floor is this minus this, so it's the actual equation minus 0.
Which doesn't matter.
Doesn't really matter, right? So that, okay, and it's going to be squared. Why squared? Because that's part of the formula. The x-axis. The x-axis. Yeah,
So what does that 2.5 do? Like, what is that? That doesn't really matter though.
doesn't even matter, it's not even part of the picture. This is the only thing that's rotating.
So when we see like an asymptote like that, it's not meant to really trick you.
No, not at all. Yeah, they won't do that for you. They won't make an asymptote in the middle of your picture. Okay? All right, so are we good so far? So this just now becomes algebra slash one-step calculus slash algebra. Remember how that
Yeah.
works, right? So if I'm looking at this thing, I have a little bit of algebra to do first. Well, quite a bit of algebra to do first, okay? So one of the things I recognize is that this thing is going to need to flip to the top. Is everybody okay with that?
Yes.
Because it's to the
Because
negative
it's
one.
to the negative, it's to the 1 down below, so it would be to the negative 1 up top. So I'd have pi from 0 to 1, 6, 5 minus 2x to the negative 1, all that stuff squared.
You're gonna have to use the substitution.
Or you can bring the negative 1 to 2, make it negative 2.
We're going to do that, and
But
yes.
you can't expand that thing out
I
if
would
it's to a
not,
negative.
right, correct, no, would not. Here's my next question, what's a mistake somebody's gonna make?
Forget to square this.
Forget to square the 6. That's really, really important. So that 6 has to be manipulated by that square as well. So keep working it slowly. I would have 36, because 6 squared, and then
Right.
I would have 5 minus 2x to the negative 2. Yes,
Could you bring the 36 out front?
I would 100% do that. I would say, oh my gosh,
Where
that's
the
a
pi
pain.
is?
Put it with a pi.
36 times 5?
Yep.
It's
So the
gonna-
next thing I would make it look like is 36 times pi from 0 to 1 of 5 minus 2x to the negative 2. Yes.
Can you only bring something out front if it's not being multiplied by x?
Yes.
So if
Although,
it's-
give me a second. What if it looked like this? Give me a sidebar. What if it was like 2 minus 4x? Can I bring the 2 out to the front?
Because it's one term.
Because it's an individual term, right? Okay? If it's attached to x like that, can I pull the 4 out? Yes.
Oh.
You see the difference?
Yeah.
Okay. So if it's individual terms, you integrate, integrate, integrate. Because this is a whole thing with x, that 6 up front is 36 up front comes out. Yes.
You probably wouldn't, but in theory, if it was the 2 minus 4x, could you factor out 2 and then bring it to the front?
I wouldn't.
I mean, you wouldn't, but
Because then you make it
Could
a
you?
unit. I would want them individually, so I wouldn't want to make them a unit. Yes, but don't.
yeah, I
Yeah,
I
yeah.
wouldn't, but just in theory.
Yeah, don't. Yeah. Yes.
Like, let's say if this was 36 plus 5 minus 2x to the negative 2, then it'd be 36x.
Correct. Yeah. Correct.
Right.
You see the difference? That's a really good lesson. Now, what's that, Clea?
Do you use substitution for this?
Yeah. Now you're going to do it the way I taught you because that's the way you prefer. Some people prefer the kind of the easier method. You make that call. Okay? So whatever one's easiest for you. So I would have 36 pi, right?
Yes.
And a lot of people like that new method where they just take the unit and do it an integral to it. So it would be 5 minus 2x to the negative 1
So
over
you don't have
negative
to
1.
rewrite the 1 with 0 because you just integrated.
Because you're now integrating, right?
Oh.
And then what am I going to multiply by down here?
The derivative of the inside.
Right, which is,
Negative 2.
right. Yes.
When you do it the regular way, are you dividing by -2 or multiplying by -2?
Remember you pull out a negative 1/2, right? You pull out a negative, you need to multiply by -2, pull out a negative 1/2.
Because it undoes that.
So it would be 36 pi over 2.
Yeah, yes.
Where's plus C? Like, you need a plus.
Do I need a plus C? Tell me why I
Do you have an
wouldn't.
A and a B?
Integral?
It's an integral, but why specifically would I not need a plus C? Good question, huh?
You have an A and a B.
I have an A and a B, so I don't need a C. Does that make sense? All right, so now I'm gonna clean her up a little bit, and I think you guys have gotten kind of comfortable with this. 36, okay, wait, 0 to 1,
Yeah.
right? I think you guys have gotten kind of comfortable with this, at 36 pi divided by 2, right? Make life easier for ourselves, that's just a whole number. All this right here is just some number, right? So what's 36 pi divided by 2? 18 pi?
18 pi.
Okay,
Negative
so,
18?
well, I have two negatives, make a positive, so I think positive.
They all cancel out. Yeah.
8. Yeah.
Did you integrate correctly? When you added one whole to your u and you put it over itself, you should put it over -1, right?
Oh, I didn't do it like that.
No, I know. I'm talking about look at your paper.
Mhm.
When you added one whole to it, you got -2, added one whole, you got -1 over -1. And then, but when you pulled out a -1/2, right? Does that make sense? Okay. So now I have 18 pi, and it's gonna be 5, do you guys agree it's 1 over?
Yeah.
1 over 5 minus 2x to the first, and that's from 0 to 1. Are we okay? So 18 pi is just kind of going for the ride, gonna go for the ride, right?
Yep.
Plug in the 1, what do you get? 18 pi is going for the ride. If I plug in 1, I get 1 over 5 minus 2, so 1 over 3.
1 over 3.
Yeah,
You gotta do the 0.
try the 0.
0 and it, yeah, it makes a difference.
It does, it makes a difference. Be careful, don't be complacent. So 1 over 5. 1/3 minus 1/5. So 5/15 minus 3/15, that's how I see it, right? So 18 pi, and then I got a common denominator. I got 18 pi times 2/15, I think you would agree.
Yes.
18 pi times 2/15, if I multiply it out, I get 36/15 pi.
Thir-
So 36/15 pi, not quite what I need.
You need to reduce it.
Reduce it by a
3.
3, good. So 12 pi over 5, smiley face.
Yes.
What do you think?
Good.
You get it, right? It's not a bad subject. Honestly, it makes me smile because this is really high-level calculus that you're working on at this level.
Pretty much what we're doing is just doing the same thing, just putting pi and square into it.
Absolutely, absolutely, 100, absolutely.
As they're already-
If you were comfortable with areas, the volumes come naturally. Things people forget. They forget pi, they forget to square it. They forget to square everything, okay? So those are like mistakes that can be made. Yes?
When you have an asymptote, like, how should you draw it on your graph? Like, you just do like a little thing, like a little
Dotted
squiggly?
lines. It's dotted lines. Straight through.
Why do you square everything?
Because the formula is pi r squared.
Okay.
Yeah. Yes.
So it's the same thing as finding integrals, just with a pi in it.
Same thing as finding area. The only difference is you have a pi in front because you're rotating and you're making it circular, and then squaring. Yes.
So on the packet, most of these are I questions, so are we gonna on the test have to do I and then this says I?
Quite possibly.
The regularization area.
Yeah. A lot of them are finding the two places at which they meet, or
The normal line, the
normal
tangent
lines,
line.
some old like review stuff. So it doesn't hurt to go back over it. Yes.
Let's see, May, June 2010/12, that's a good, washer method.
Okay,
Like
let's
it's,
do it.
where it's like, not together.
Not touching.
There's a hole.
The Walter method.
The washer method is where there's a hole.
Which one?
There's a hole. Okay, can I erase this one? Is everybody good?
I'll just watch the videos.
You
May,
wanna
June
watch the video?
2010/12, number 11. We did that in class?
Oh, yeah, of course.
Everyone knows it.
Ooh, I don't know.
Wait, number 11. We didn't do 11. We did. No, we didn't. We did 2.
Yes.
Did we already do it?
No, we did 2. May, June 12.
Okay.
It's a lot of pages. See what that much is. It's like. Number 9, yeah.
October, November 2006, number
I
8.
say, I don't know.
Thank you.
Oh, it's October, November 2010/12. For some reason I wrote May, June.
Did you?
Yeah.
Can I take it from you real quick?
It's this one.
Which one?
Okay.
Okay, this one. Oh, no, no.
2010/12. Okay, so
Is that the positive?
I think it's just a positive.
I think it's to the 1/4.
1/4.
Yeah.
Terrible, terrible, sorry. Can't read that small stuff. You gotta have to slow it for me a little bit. just an ounce. Okay, so the diagram shows part of a curve, y equals 3x plus 1 to the 1/4. The curve cuts the y-axis at A and the line x equals 5 at B. We'll do part I as well. Show that the equation of the line AB is y equals negative 1/10 x plus 1. So yes.
Right. Well, yeah, I did that part. What I did was I found the coordinates for A and B,
Okay.
and then I found the slope y2 minus y1 over, and then I got the equation from that.
Perfect. Perfect. So what he said was, for me to be able to find this unknown line, straight line, right? He said, well, if I know this ordered pair, and I know this ordered pair, then I could use the y2 minus y1 over x2 minus x1 to find the slope, and then use my favorite formula. Yeah. So let's go through that process. A is here, right?
Yeah,
Then-
x is 0.
and that's B. So you just got done telling me that for A, x is 0. Okay, how do you know that? What is it called?
Because it's on the y-axis.
Right, so y-intercept, right? And then B,
X is 5.
x is 5.
Oh, good. Just plug those in.
And you just plug them in to the curve. Why? Because that's the place at which they cross,
Yeah.
right? Because the curve and the line share that point with 0 for x, and they share that point with 5 for x. Is everybody okay with that? So if I plug in 0 here, I get 1 over...
1 over 1, which 1, yeah.
Yeah.
So 1.
Perfect.
Yeah.
So it's 0, it's 0, 1. Are we okay? And then for 5, so I have 1 over 16 to the 1/4. And what's 16 to the 1/4?
2.
2. So 1 over 2. Does it make sense that it should be smaller than 1?
Yes.
Because the line goes down, right? I mean, if we got 10 in our answer there, we'd be like thinking about what we might have done wrong. Hopefully we recognize that. Okay, so we're at a point now. We know our two ordered pairs. So can we actually find the slope of AB? Sure. Good old-fashioned. And how many points is this good old-fashioned?
4.
Oh, that's not bad. It's not bad at all.
So today that's like 3?
Yeah, probably 3 in today's world. So we're going to do y minus y over, right? You see I'm going to be consistent. I put 1 first. So 0 minus 5. Everybody okay?
Yes.
Oh, we're good? Ian, you're good? Okay, 1 minus 1/2 is 1/2, and 0 minus 5 is -5, really -5 over 1.
Yes.
Because I want a fraction divided by a fraction because it's easier to work with. I'm going to flip that guy up and multiply by the reciprocal. So I have 1/2 times -1/5, which is -1/10. So the slope is -1/10. Are we okay?
Yes.
Okay, so we found the slope. Now can we find the equation? Well, we're going to use my favorite formula in the world. And which ordered pair would I use?
The A is easier.
A is easier, right? So y minus 1 equals negative 1/10 times x minus 0.
Yeah.
Is everybody okay?
Mhm.
So y is equal to negative 1/10 x plus 1, because I multiply the 0 through and add 1. And that's what I was looking for?
Yeah.
Yep.
So if you plugged any other order pair, it would be the
You would get the same thing. Yeah. Kind of cool how that works, if you ask me. Okay, so now, are we in a good spot where we found AB? What are other ways that potentially we could find lines in these types of problems? What are other ways that we have used to find lines? Yes.
Well, if you have the equation of two lines and you know they intersect, you can set them equal to each other.
Okay, that's one. Set them equal to each other, find the ordered pairs. That's a good question. That's a good thing that we could do. What's another thing that potentially could come up with these types of questions? I'm just thinking like a teacher, like what kind of questions might come up on an ACE exam? Anything else? I think this is an oddity that they actually gave you 2 points that you actually use y2 minus y1 over x2 minus x1, because we haven't used that in a long, long time.
Right.
Mhm.
What do we normally use to find the equation of a line?
Isn't it usually we solve the kind of normal way?
What's that?
Isn't the like we just solve the normal way next to it?
Like a normal way, but what has become our normal way? I guess my question is really not an easy question. What is it? Yeah, derivatives, right? Beautiful, thank you. So
Yeah.
derivatives normally is the way they go. Normally they'll give you they'll say that one of them is a tangent to the other one, and they want you to take a derivative and find the actual slope, and then, so think about that. They could do this type of problem in multiple different ways, one of which could be derivatives to find the equation of a line. Yes?
They could do normal line.
Yeah, they could find a normal line as well.
Yeah.
So you have to kind of think outside the box. Remember, when I teach you the concepts, I can't tell you these are exactly the ways they're going to ask you the questions. We just have to be able to use all our tools to kind of make the answers come about. So, all right, so now we're at a place where we have this line. We know it's y equals negative 1/10 x plus 1, right? And then we know we have this curve, which is 1 over 3x plus 1 to the 1/4. I'm going to assume it's going to rotate about the x-axis.
Yeah.
Yeah, okay. So are we having a party or not?
No party.
No party. But there is a hole, right?
What
So
does
there's,
that mean?
okay, so if I'm rotating horizontally, it's kind of dull. If I'm rotating vertically, I'm having a party, right?
Okay.
You'll see my video. I had corny jokes involved as well.
Okay.
Yeah, so I know you're surprised about that. So what we're going to do now is we're going to find a place at which it rotates. So this guy comes over here, comes down through, and comes back up, making some random three-dimensional shape. I don't know, the flower.
Sausage.
So,
Sausage sounds good. Hungry. Yes.
so when we do
The rotation?
yeah, we'll do pi. Are you doing pi for this one too?
I hear you. What?
Do you use pi for this?
Absolutely.
Where are you getting pi for every single one?
Because it's a rotation, and when you cut it, you literally see circles.
Okay.
Okay, so it's going to be, let's talk a little bit about how that works, because I think last time I did this one, somebody said it was truly beneficial to draw what the outer and the inner radius, I think we talked about that in this class. So my outer radius starts here, at the very top of the ceiling, and it works all the way down to the place at which I rotate, which is 0 in this case.
Okay.
Okay? Then my inner radius starts at the bottom of the picture, and it works its way all the way down to the place at which I rotate. Okay?
Yes.
So what we are basically going to have to do is we're going to have to find the outer radius squared minus the inner radius squared. So it's going to be pi from what to what?
0 to
0 to
5.
5. 0 to 5. Why 0 and 5? 0 is my leftmost x, 5 is my rightmost x. Okay, those are my walls. So what's my ceiling? Okay, I'm looking at purple. What's my ceiling to floor in the purple one? Negative 1 over 10x plus 1, and then minus 0, so that doesn't
Right.
matter, right?
Yes.
And then what do I have to do that?
Square it.
Square it, that's right. So far, so good. It's going to be ugly.
Do you subtract?
Then I minus inner radius. What's my inner radius?
It's 1 over 3x
Can you just bring that up?
to 1/4.
You want me to bring it up right now?
Yeah,
gonna be easy, just so it's easier.
Okay, so what am I gonna say?
3x
3x plus 1 to the negative 1/4.
And then all
Oh, that's awful. Fourth squared. Wowee. Yeah, they made this fun. Okay. Are we okay so far? Does everybody understand which one's the outer radius and why the one that's the inner radius is what it is? Questions about that? Does anybody have any problems why we're squaring each individual piece? Does anybody need to know why subtracting? The actual formula, just FYI, is from A to B of the outer radius squared minus inner radius squared. Okay? In this case, my outer radius is purple, my inner radius was red. Are we good?
Yep.
So, the thing here, it's telling me to square. What do I need to do first?
Foil it.
Foil it out. Because remember I told you, do as much algebra first, then come back to the calculus. So really I'm taking negative 1 over 10x plus 1 times negative 1 over 10x plus 1. Ooh, that's going to be pretty. Yeah. So what does it do? Negative 1 over 10x times negative 1 over 10x is 1 over 100
X squared.
Yucky.
Ooh.
Yes.
You can't use substitution with that?
No. Well, I would.
Because couldn't you do this over
If you
3?
could foil it, you shouldn't. I mean, we could. We could try it.
Hey, got a question.
Yeah.
Are you gonna give us a question on this on this?
I don't know. I haven't looked at it. I haven't made a test yet.
You should not.
Okay. And then minus, what's that going to be?
Negative 1/10.
Negative 1/10
X
minus
minus
1/10. So
1/10.
negative 2/10. Negative
Yeah, negative 2/10
2/10
x
x
plus 1.
Again, just algebra until I can actually combine like terms and do calculus, okay? And then what happens over here? I have one more thing I can do to clean this up.
3x plus 1 to the
To the negative 1/2, okay.
Yeah.
So to the negative 1/2. All right, cool. So I'm going to integrate, use substitution. Do you guys see that?
Yes.
Okay, do you guys see why integrate, use substitution? And that's okay, just handle them as their own little place. The the 1 over 100 goes for the ride, so it's 1 over 100, and then what's this?
x cubed over 3.
Yep, so far so good. Are we okay?
Yep.
Next one,
X cubed of.
I add one whole, yeah.
Over
okay.
that exponential
So I'm
power.
gonna make this 1/5, negative 1/5. And then what's this?
X squared over 2
Good. We'll clean that up in a second.
plus x.
Plus x, good. Phew. Okay. Yeah, you do it the old-fashioned way, use substitution, or the new way, however you choose. We got 3x plus 1. If I add one whole, I get
1/2
1/2
over 1/2.
over 1/2 times
3.
Just to, oh god.
Typical.
Oh, just give me a second. This is
I'm
9
giving, okay, let's give Clea a second. Is it a 9 point?
9 points.
That bottom part is 9 points?
Yeah.
Yep. It's the big one,
Love it.
which today's 8
That's
points.
very unusual. That's very unusual for it to be that. Well, it's pretty extensive. Okay, so while we're waiting for Clea to finish up she's there. She loves that use substitution. What I want to do is just still clean up algebraically now. I see, I'm gonna bring it over here. So the whole thing is worth like, what, 13 or?
Yeah.
Wow.
Yeah.
Wow, that's a good one. Okay, so pi is gonna go for the ride, right?
Yes.
I have 1 over 300, you with me?
Yes.
X to the third. And then minus x squared over 10.
Yes.
I could put x cubed over 300 if I felt comfortable, yeah?
Yep.
I like that better too. Let's do it. X cubed over 300.
Wait, what?
Yeah.
300.
Those are big
Well,
numbers.
3 times 1. Yeah. Don't do that. Okay, and then cleaning that up, you guys told me 3/2 on the bottom, therefore 2/3 up here,
2. Yep.
right? And then 3x plus 1 to the 1/2 from 0 to 5. Really, they're gonna give us a 5 there? That's huge. You see me getting a little nervous.
Oh, well, you're dividing by something big, so.
I get nervous. Okay, so I'm gonna plug in 5. So I've got pi, goes for the ride.
Yes.
I've got 125 over 300, because 5 cubed, right? Minus
25 over 10
25 over 10
plus 5.
plus 5. Oh, okay, I'm good. Plug in my 5. I get 15 plus 1 is 16 to the 1/2. 4.
4, yeah.
Square root of 4.
So,
Or square root of 16, which is 4.
yeah, it's 4. So 8/3.
Oh my gosh.
Wait.
Okay, I'll do it again. So I plugged in 5 here. I got 15 plus 1 is 16. Square root of 16 is 4. 4 times 2/3 is 8/3. So that was plugging in 5.
You have to subtract that from the 0?
Minus parenthesis.
Oh, wait.
The 0 doesn't do it.
Wait, the square root of 16 is
Wait,
4.
did you close the other parentheses?
No, I'm going to do it at the end.
So it's plus, it's 1 to the 1/2.
Because this right here. Did I answer your question? Sorry.
Can you do the 15 plus 1 equals 16, what is that?
Yeah. This is 16. Square root of 16 is 4. 4 times 2/3.
Oh, 2
Yeah. Now,
Would it be
play this game with me for a minute. If I plug in 0, right? I've got 0 here,
minus 2?
0 here,
0.
0 here. So the only place that 0 matters is here. So it doesn't really need to, so minus 2/3, and then if I plug 0 in here, I get 1 to the 1/2, right? Because 0 plus 1 is 1 to the 1/2, so times 1.
Right.
Close parenthesis.
Alright.
So minus 2/3 is really rather plus 2.
Oh my.
It's a lot of
Yeah,
pro.
I'm assuming you guys are going to use your calculators for this.
Yeah.
I'm assuming you're not going to do like I do. Actually, look at this. Isn't that negative 8/3 plus 2/3 would be negative 6/3, which is negative 2?
Oh, yeah.
Yeah, it's kind of cool.
Calculator, which is 11 over 12.
What'd you get for the whole?
11 over 12, so it'd be 11 pi over 12.
Oh, so the whole thing is 11 pi over 12?
Wait a minute.
How? Wait.
Oh my
Okay. 1 point.
Yeah.
I knew it would faster.
So yeah, we're gonna check it. We know pi is in the answer. Got that?
Thank goodness.
That's a good problem.
No way. No way.
No?
This okay. So he said, what happened with the negative 8/3 minus? So negative 8/3 plus 2/3. So
Which would be
then
negative 6/3.
negative 6/3. So
Which is negative 2. So it's minus 2. Which is so pretty. Compared to, yeah.
then I got 0.916 pi.
Yeah, which is 11 over 12.
Yeah. So 0.916 pi or 11 pi over 12.
But they'll accept the 0.916.
Do you have to round it? What do you?
So then it's like 3 significant figures.
So it would be 0.917 because it's 6 repeatedly.
It's what?
It's 6 repeating, so it'd be
Significant figures you don't round though, do you?
Should you though?
I don't think so. Okay, let me find one that's modern, like in 2014 or 15, and see how it compares. Find one and try it without me, and I'll see. Um, 2014, October, November 2014, 1/12.
Is it a hard one?
I think it's a good one.
You like this one?
No, I mean, I won't give this one again. And I'm telling you, this one's far and few between.
Is it a y-axis rotation?
Oh yeah.
Is it washer?
Are we doing?
Washer on the Y.
Are we doing the y-axis one on the test?
Well, I don't know if I can find one.
Is there gonna be any extra?
Probably not. Okay, it says the diagram shows part of the curve of y equals x squared plus 1. Find the volume obtained when the shaded region is rotated 360 about the y-axis.
What's the shaded region?
And this is the shaded region. And it's about the y-axis, and it's worth 4 points.
We're having a party.
We're having a party, baby.
There's no
Zero to 10 is gonna be 1 to 5.
So, we are having a party, right? And we're rotating about the y-axis. Things to remember when having a party, right? Everything must be in terms of y. So, for currently, what are my x values?
2 and
0 and 2.
0 and 2, and I gave you the answers. Because I asked you and did it.
So it's gonna be 1.
So, and then how do you know that? Well, we were looking now at your y is 1.
So it's when it touches the y-axis, not the x-axis?
No, when
Everything
it's
is in terms of y.
See how the rotation happens
Rotating
here?
around the y?
See, you're having a party.
Because, yeah.
Like, it reminds me of those toys where you hold up and like they make that noise and you like wrap it around.
Right, you're excited. Okay, so now things to remember. Everything must be in terms of y. So this is going to be from 1 to 5, right? And if I tilt my head to the right, ceiling, floor.
ceiling's
The
the
square
line.
root of
Ceiling's that,
And then 0,
a 0.
So
so just
Because you gotta-
x squared plus.
It would be
y, square root of
It's-
y minus 1.
because everything must be in terms of y. So this is the square root of, and normally it's plus and minus square root, right?
Yeah.
But we don't care about the minus because we only care about the right-hand side.
Right.
So,
and then we're squaring.
and we have to square it.
So it's going to be
What just happened?
Thank you.
Okay, so for us to do party,
Right?
we have to do everything in terms of y.
because it's a
So,
y-axis
We
rotation.
had to get the x values in terms of y, we had to get the ceiling and floor in terms of y.
Okay.
So this is going to be the square root of, so to the 1/2 squared.
Check
So
this
just
out.
one-
Yep.
It's really not a bad problem.
It's the square root of y plus 1.
You just
have to know, like.
You have to know. So then you have pi from 1 to 5, and if you do that, you get y minus 1. And remember, your floor was 0, so that really didn't matter. So this is going to be pi, and if I integrate now, I get y squared over 2
That's weird.
minus y from 1 to 5.
Then you just plug in.
Pi is going to continue to go for the ride. 25 halves minus 5 minus 1/2 minus 1. Well, that's really not a bad problem at all.
See,
How many functions?
4.
25 halves.
Do we have to stop?
So you just plug in 5?
Plug in your 5 and plug in your 1 and subtract them. So 25 minus 10 is 15 halves, minus 1 is 9 halves,
Wait, how'd you get
plus 1.
8
11 halves, I don't know.
is in 25 halves, parentheses, minus 5, minus, or and it's actually plus 1/2, right? Yep. See. I got 25 halves, minus 5,
And then,
plus 1/2.
yeah, because it's plus 1/2, right.
8.
8 pi.
I got 8.
Wow, that's exciting. What do you think? Good stuff?
Easy.